Hello everyone. We are going to start a new program, uh, design of embedded retaining wall, Eurocode. Just like what you see on this picture, this photo. Okay, this kind of wall, this kind of retaining wall. How do you design it according to Eurocode 7? So we already completed one Eurocode program, and that was Eurocode in general. Okay, so now I want to go in detail for each structure, how to design Eurocode, how to design each structure according to Eurocode, and with in a way that I can give you like more detail. Okay, so we will do design according to Eurocode for embedded wall, footing, and pile foundation, like retaining wall, like gravity walls, like everything. But this time I will take like one chapter in the previous program. This, for example, was one chapter. But this time, this whole course is focusing on this embedded wall. Okay, and I have to mention it. This is mainly based on UK standard. Okay, this part. So we are going also to see French one, because in the Eurocode also there are some small detail like national annex of each country that make it different from one country to another. Okay, so if you want to learn how to design embedded wall according to Eurocode 7, so you are at the right place. So this is the content of this lesson, this program. Uh, Actually, it is supposed to be one chapter of Eurocode, but I will take it as the program this uh, and divide it to enter and give more detail. Okay, so I'm going to explain really slowly, so some people might find it maybe boring. So the first point, we will talk about ground investigation. So site investigation depend on the structure you are going to build. Okay, so we are going to see here what kind of investigation you need if you are going to build embedded wall. Okay, design situation and limit state, basis of design, limit equilibrium method, soil structure interaction analysis, design for serviceability limit state, structural design, and monitoring, supervision, monitoring, and maintenance, and the summary of all this. And at the end, we will finish up by worked examples, okay, typical example of design. Okay, so I recommend you go and watch already on my YouTube the Eurocode courses we did already. There are some Eurocode lesson we already did. So that is for good starting. You might won't need to see them first. Okay. So today we are going to focus on this first part. Uh, Design embedded to design for embedded wall, retaining wall, and first point, ground investigation. Okay, it will be very short, just introduction, and for each video we will go 1 point. Okay, so ground investigation. What do you need if you want to do ground investigation for retaining wall, embedded retaining wall? Because there are two types. So just to make sure we understand what we are talking about, you understand what I'm talking about. I am talking about this kind of walls, okay? In case you want to build like a underground space, sometimes you need. So this is just anchor being installed, yeah. So normally, if you are watching this, you should know what this kind of word means and what is these anchors. Okay. And sometimes you have this kind of thing. This is sheet pile, retaining wall with sheet pile, but this one is like a diaphragm wall. Okay. But the design is kind of similar. Okay. And you can have this is the same one in the first slide, on the first slide of this program. So when you have to build underground of a building, so you can see some column coming out, foundation. So how do you design this kind of wall? Okay, so that it can be stable. Or sometimes you need cofferdam. Okay, so here you don't have only soil, but you also have water, or you mainly have water to uh, retain. Okay, how do you design this? Or sometime this is new, you can use it for like a foundation of bridge, okay, or interchange, or this type again. Okay, this is maybe a new technique. So anyway, this first is to show you what we are talking about. Okay, how to design this kind of retaining wall, embedded retaining wall. Okay, so this is the program. So now let's proceed with the investigation, ground investigation for this. Okay, before you build anything, you need to do some site investigation. Okay, sorry about this. So first, we are going to talk about depths, the depth of investigation. If you are going to do like some CPT or SPT or boreholes, how deep you have to go for your project. Okay, so this is what we are going to see first. Okay, so we are going to call the depth of the investigation ZA. Okay, for retaining structure. So this figure will help us to illustrate uh, everything. So you can see here the wall, this side, okay? So we have several possibilities, okay? Several possibility. For example, you have situation of, for example, this wall. Can you imagine that this wall and this one are not the same, okay? Separate. So this wall, for example, if we take this one, you can see you have possibility that the water level is really under this this position. Okay, it's lower than this position. Or you may have this situation where the water level is above the excavation. You can see, yeah. Or you may have this kind of thing. You can see that this is mixed soil and water, okay? But here you have mainly water. The mean of the seed pile here, or I'm sorry, not seed pile, let's say the wall, okay? The embedded wall here is to stop the water, okay? So for each case, you may have, you will have a different value of ZA. Remember ZA, what is ZA? The depth of investigation, okay? How deep you need to go. Because you need to know what type of soil you have on your site before you build everything, okay? So for the case where the groundwater table is below the excavation, like here, okay? You can see this here. So if you have this, you need the value of ZA to be this one or this one, the biggest one. The biggest between this one and this one, okay? 0.4 H, small h, you see h here, okay? So the height of the wall here, or let's say the depth of your excavation, 0.5 times deep. So ZA, this value of ZA need to be 0.5 times this value. Or T, where is T? T is here. but you can see that T is almost same as like the embedded length. Okay, H is the part of wall above the excavation, and T is the part of the wall below the excavation. So T plus 2 meter, T plus 2 meter, okay? 0.4 times H or T plus 2 meter, okay? So means from here, this plus 2 meter. So the biggest between these two should be your investigation depth, okay? So you should investigate to find out the soil, all the soil layers from the soil surface until ZA. Okay, that is the case where the groundwater level is below here, this case. Okay, the groundwater level is below, so you don't have to worry about water here. Next, when you have now the case where the water level is above the excavation, like here, for example, okay? It doesn't have to be here, or here. It just has to be above this excavation. In that case, this is what you have to respect. The ZA need to be H. What is H now? H is here. Can you see from the bottom of the excavation to the water level? Okay, the definition is really clear. Okay, the capital letter H from the groundwater level to here. Okay, plus 2, H plus 2, or the same one here, T plus 2 meter. I already explained this. So the biggest between, the greatest value between this and this, that should be taken. Okay, but you have to make also sure that ZA is at least bigger than 0.4 H, like this one also is respective. So if you want, you can add this one also. So biggest between this one and this one, or this one. Okay, because sometimes the water level, it might be, for example, here. So you can see that capital H is small in that case. Okay, so I hope it's clear up to now. So next, you might have this situation also where the groundwater is above the water is above the formation, and no impermeable. This is another case, eh? No, no bedrock is found. Okay. For example, you have this situation, the water level is above the excavation, and in the underground there is no impermeable layer, there is no bedrock. So in that case, you need to verify this to get this. ZA should be at least equal to T plus 5 meter. Okay, T plus 5 meter. You should go deeper. If there is no rock, there is no bedrock or impermeable layer here in the underground, you should go at least this one, T plus 5. Okay. Okay, let me put this everything here. This is what we have for the water level above, below the excavation, above the excavation, and this one is when you don't have a impermeable layer down, so you have to go this deep. So I think this is, in many cases you have to verify this. Okay, this is, it doesn't matter you have below or above, huh? You have to verify this, at least 5 meter this below this tip. Okay, 5 meter below the wall tip you have to go, because it is T plus uh, 5 meter, maybe. Okay, so if now the wall is meant to cut off groundwater, like in this case, okay, you can see the water flow, you cut it. It is prevent this wall is built to prevent the water flow. Okay, so in that case, the investigation should extend at least 2 meter into the impermeable layer, because this layer is impermeable, you see. So the ZA here, in this case, should be at least two 2 meter. Okay, it should be at least 2 meter from here to here in the rock. Okay, so this ZA, it may be limited to 2 meter if the wall rests on rock, for example, on this kind of layer, very competent layer, very competent soil, and if you know very well that layer, maybe the rock. Okay, but if the geology of this rock, for example, is not known, is unknown, or you're not really sure what it is, then you should go up to 5 meter. Okay, 5 meter. So the minimum is 2 meter if you have this kind of situation. But if you are not sure about this, the geology of this rock, of this impermeable layer, then you have to go 5 meter. Okay, so but this is just like a guideline. Okay, if you have very complex project or large project or ground where the geology is not really good, then you might go even deeper than the indicated value here. Okay, so these values are not universal. Okay, it's just to give you beginning, starting, but you have to consider sometime uh, going deeper when the project is complex. Okay, okay, next we are going to talk about spacing. So now we finish about the depths of investigation, how deep you have to dig, or you have to go for CPT or SPT. But what is the spacing between one point of investigation to another one? Okay, what should be the minimum distance between these, or the maximum distance? Better, maximum is better. So this Eurocode is giving this information for spacing depend on the type of structure. Okay, so for example, if you are dealing with high rise and industrial structure, so you have to choose the spacing is around this, and you do like grid this kind of perpendicular lines for this spacing. Okay, but in our case we are designing embedded wall, so it is here. You can see some linear structure like road, railway, channels, pipelines, dikes, tunnels, retaining wall. So the spacing should be this between 20 and 200 meter, okay, according to Eurocode. So it will still depend on the site. So if you see that the soil is not changing too much, the variation is not that much, maybe you can go for smaller steps. But if it is, you can go for larger steps, 200. But if the site is changing too much when you move away from one point to another, then you might consider small steps. Okay, yeah. So it depends also on the budget, the project. Okay, but these are just some orientation examples. You might have uh, other guidelines somewhere else. Okay, these are just for starting point. Okay, so that is what I was saying. It should be adjusted for site specific condition. Okay, each site has its own condition, so that's why you have interval. You don't have a one value, typical value like that. You have intervals. Okay, so if the site is complicated or the structure also is very important structure, so you need to go with smaller steps. Okay, so you have to consider geological variation and the type and size of structure. If the structure is very big, then if it is very important, for example, let's say retaining wall for to prevent, for example, flood, inundation, that is very important. Okay, so you have to consider going small steps. So that will be all for this introduction. This is the first lesson for this program. We will continue until the end, and I hope we will learn something together. Thank you very much for your time, and see you next time. Thank you.